Using relational operators on a vector or matrix results in a logical vector or matrix. So for example, here's a vector vec. If we say vec greater than 6, then what's going to happen is it's going to go through the vector element by element, comparing each element to see whether it is greater than 6 or not, returning logical 1 for true if it is, or 0 for false if it isn't. So 44 is greater than 6, 3 is not greater than 6, 2 is not greater than 6, 9 is greater than 6, and so forth. So what we end up with is a logical vector, a vector in which every element is a logical value, either logical true or false. Once we have a logical vector, we can use that to index into a vector or matrix. But again, this only works if the index vector is the type logical. So if I say vec, in parentheses, my logical vector, log v, then what happens is it gives me only the values from vec for which the corresponding element in the logical vector is true. So the 44, the 9, and the 11. In other words, the first, fourth, and fifth elements in the vector. So what I end up getting here are the actual values in the original vector that were, in fact, greater than 6. MATLAB has built-in true and false. False is equivalent to logical 0. True is equivalent to logical 1. False and true are also functions that can create matrices of all false or true values. So they create logical matrices. MATLAB has several logical built-in functions. The first one is any. The function any returns true if anything in the input argument is true. Recall that any non-zero value is a way of representing true. So my vector vec has a lot of non-zero values, so any of vec is going to return true. If I had a vector of all zeros, then nothing would be logically true, so any of z would give me 0 as a result. The function all returns true only if everything in the input argument is true. So here with my vector vec, everything is in fact a representation of true, so all of vec gives me true. If we have zeros, then all of z is going to give me 0. The function find finds locations and returns the indices. So here's repeat of my vector vec. If I said find vec greater than 6, then it's going to find the elements, the indices of the elements for which they are actually greater than 6. So in this case, the first, the fourth, and the fifth elements, the 44, the 9, and the 11, in other words, are greater than 6. But what I get is a vector of the indices. On the other hand, if I said something like find vec equals to 100, well, nothing in the vector is equal to 100, so there aren't any indices to return, and instead what we get is an empty matrix. In other words, there weren't any. The is-equal function can compare two arrays, either vectors or matrices, as long as they have the same dimensions, and returns logical true if they are equal, so in other words, if all of the corresponding elements are equal to each other, or false if not. So here two vectors, v1 is 1, 2, 3, 4, v2 is 1, 0, 3, 4, is equal. No, they're not equal because the second elements are not the same. If we said v1 equals v2, notice that doesn't just tell me true or false whether the two vectors are equal. What that will do is go through element by element and tell me whether the individual elements are equal to each other. So all of v1 equals v2 is the same as using the is equal function. There are element-wise operators for or and, which is a single vertical line and a single ampersand. These are used for arrays, and what they do is they go through element by element. So again, that means the arrays have to have the same dimensions and return either logical 1 for true or logical 0 for false. So here are two vectors, v1, v2. If I say v1 or v2, that'll go through element by element. So in other words, 1 or 3, those are both true, so we get true or 1 as a result. 1 or 0, true or false, gives me true. 0 or 0 gives me false. 5 or 1, that's true or true, gives me true as a result. Remembering that everything that isn't 0 is a way of representing true. With the AND operator, I get true only if both are true. So the first elements, the 1 and 3 are true. The last 5 and 1 are true, but the other two give me false. So these are used for arrays. The doubled vertical line and the double ampersand, those are used only for scalars.